This is the third and last installment of the Git for Beginners trilogy. In this video, we're gonna see how we can collaborate with other people using Git remotes and GitHub. Just like in the other two videos, we will be using the Git command in the terminal and in parallel the Git client inside Visual Studio Code. We are also adding the GitLens plugin to Visual Studio Code to account for the missing functionality. If you missed the first or second video in the series, please check them out. We covered a lot of ground. The second video will show up as a card at the top, and let's get started. The way in which we can collaborate with other people on a Git repository is by using Git remotes. And let's say we have this repository with a single branch, master or main, and two commits, M1 and M2. And a Git remote is a mirror image of our repository that is hosted remotely. It can be hosted on the internet or on our local network. There are commercial services like GitHub and Bitbucket that can host Git remotes, but also we can host it ourselves by running a Git server. Once we added a remote to our repository, we can interact with it by pushing and pulling changes. So let's say that in our local version, we add a new commit M3, like this. And now the end of the master branch is M3. Now the remote is out of date. It doesn't have an M3, it only has M2. But after we do a git push operation, the remote will also get M3, and the master branch will be identical to our local version. And also in the same way, let's say one of our colleagues added M4 commit to the remote, like this. Now our local repository is out of date, but we can make it up to date by pulling the changes, and that will bring over the M4 commit, like this. And also it will move the end of the branch to M4, and now they're identical again. Branches work similarly. Let's say we create a new branch on our local repository. This commit will be F1. Actually, let's do straight lines. So this will be the feature branch. Now we can push this branch to the remote repository. So then the remote will have this branch. Let's see, like this. And now, of course, if we add some commits on the feature branch, then we can pull them in our local repository, and then we will be up to date. Even if you are working alone, it is still worth using remotes. For example, I create GitHub repositories for all the projects I work on, regardless if they're projects for clients or if they are personal projects. Most of the times these repositories are private, and I just use GitHub as a backup. But some personal projects I would make public and use them for a portfolio. Technically, we can have as many remotes as we want, but what happens in practice when a team of people work together is that they will all share a single remote. So let's say that on the left is the repository that we work on, and this one on the right is the repository that our colleague works on. So we will both use this remote on top, and the name of this remote usually is called origin. So origin, this is a standard name, just like master or main is the name of the main branch in the Git repository. Origin is usually the name of the first remote that we use, and usually is the only remote that we use. And now, let's say if he adds some work to his local version, like M5, he will then push it to origin. So origin gets M5, and then after he did that, we will pull the work that he did from origin. So we never communicate directly. So he never sends me work that he did, but he pushes it to origin, and then I pull it. And he doesn't need to tell me immediately after he added a new commit. We periodically pull changes from origin in order to make sure we are up to date. We will replicate the same setup in this video, and origin will be hosted in GitHub in a private repository. And well, the instance here on the left, I will name it left, and the instance on the right, it will be named right, and they will both be hosted on my computer. We can now create the repository. So we'll go to github.com, create a new repository. We are gonna call it git3, and we'll make it private. You can add a README file if you like. We'll choose not to. So create repository. And in order to initialize the repository, we need to either add the one file like readme.md. We can follow the instructions there. Or if we already have a repository with some commits, then we can upload these commits to our new repository by following the instructions in here. In our case, we're just going to create a new file. Let's say file.txt. And we are going to add one line in there. And here we need to add a commit message, and our commit message will be M1. So we click commit new file. And now if we go to here to the history, we will see the history of commits, which is only one commit, M1. We can now create the two repositories left and right. So if we navigate back to our landing page for our repository, if we click this button in here, we find the URL of our repository, and we can clone, we can pull this remote to our local machine using git clone. And I opened this terminal that I split in two, and it has two sides. Here on the left side, we are going to use the left repository, and on the right side, the right repository. So the command is git clone, then that URL from GitHub, and then the name of the directory in which we want to replicate. So in here, we will do left. And on the other side, we will do git clone and right. So now we can open Visual Studio Code in both of these directories. So if we do code left in here, this will open it for the left repository. It says right here at the top. And in here we'll do code -n for forcing a new window, and then right. And we see that it opened another instance, and if we check out the file txt, it has the M1 line we added when we initialized, and both repositories have the same version. If we want to look at the remotes that our repository has, we can use the git remote subcommand. So actually we need to be inside left in here and right in here. So if we do a git help remote, it will say that it is a command with which we can manage the remotes of our repository. So we can list all the remotes that we have. We can add new ones, rename existing ones, remove them, and so on. So if we do git remote, we will see that we already have an origin remote, and the same in right. So if we do git remote, also list origin. And in Visual Studio Code, in the source control tab, there's a section remotes, and in case you are missing this section right here, it is because we are using a Visual Studio Code extension called GitLens, so L-E-N-S. This one from here, make sure you install it and enable it. So in here we see that we have origin, and it can give us a bit more information. It says the URL of the remote and the branches. Next, we will create a change in our left repository, push it to origin, and then pull it from the right repository. So we'll go to the Explorer, to our file.txt, and we are going to add a new line, M2. Now we're going to stage it and create the commit M2. At this point, only our left repository has the M change. And we can actually verify what our remote has by going to GitHub. And once we're on our repository, we click here on the history where it says one commit. We can reload this page. We see GitHub only has M1. And that's because we haven't not pushed yet the changes from left to origin. And there are a bunch of places from which we can do this. We can click on sync in here. When we go to branches, we see that our main branch is highlighted with green, and there's that button that says push, so we can try it from here. Let's try to push, and now if we reload the history in GitHub, we will see that it also has M2, and if we take a look at our code, we see that it says M1, M2. Now we need to pull the M2 change from origin into the right repository. So if we go here in the remote section of the right repository, this will list the origins that we have. And if we expand, it will list the branches that the right repository knows about origin. So the right repository might have incomplete information about origin. So, and we'll see an example. So if we expand this main branch in here, it only lists the M1 commit. However, there's this button in here that says fetch. And what fetch will do is it will pull all the branches that are on origin, and it will bring all the branches up to date. So we can fetch all the branches, or we can fetch a single branch. In our case, we can fetch a single branch. So if we refresh it in here, we will see that right now the right repository knows that the main branch on origin has an M2 commit. So now if we go to branches, it will highlight the main branch with red. This means that our main branch is out of date. So now we can press this button that says pull, like that, and then now the right repository also is up to date. It has M1 and M2. Now we're going to add a commit on the right repository and transfer it to the left repository via origin, but this time we will use git commands in the terminal. So we are on the right repository right now. We're going to add a new line in here, M3, and we'll go to the terminal. So if we do a git status on the right, we see that the file was modified, and we will use the git add -p. This is a new command we haven't used before, and it will just launch this interactive git add. So right now it tells us that we added the line M3 to file.txt, and we can decide if we want to add it or not. So we have the options yes, no, quit, etc. We'll do yes. So now if we do a git status, we see that file.txt was staged. So we'll add a new commit. The commit message will be M3. So git commit -m M3 git status. So this time, if we want to push the M3 commit, we use the command git push. And if we go to GitHub to the repository, we see here it says 3 commits. We have M1, M2, M3. And if we check the contents of file.txt, we see that it has all 3 lines. We can now go back to the terminal and on the left side, so the left repository. So we know that the git branch command, it shows us the branches we have in our local repository. But if we run a git branch with -a, it will also show us the branches that our remote has, so that origin has. And in here we see that we have origin main. So if we do a git log to see the history that the origin main branch has, we will see that only has M1 and M2. And that's because our left repository did not pull the changes yet from origin. And we can do that by using git fetch. If we run it like this, it will update all the branches from origin and also pull in new branches. But we can also restrict it to simply origin main like this. And now if we run git log origin main again, we will see that origin main has M1, M2, and 3. But now the main branch is also a different branch. It's not origin main. So if we do a git log on the main, we see that main only has M1 and M2. And there are several ways in which we can bring the main branch to match origin main. If you are very confident in your rebase ability and you understand perfectly what rebase does, then maybe you can use git rebase. But if you're a bit unsure, then it's better just to use git merge. It's a much safer choice, and it will bail us out many times. So now if we do a git branch, we are on the main branch, and we simply merge with the origin /main. And now if we do, so the merge was successful. And if we do a git log, we see that we have M1, M2, and 3, which is what we expected. And if we look at the contents of our file, we see M1, M2, and 3. Git also has a power command that combines the fetch and merge, or if we prefer, fetch and rebase commands into a single command. And the name of that command is git pull, which pairs it very well with the opposite command, which is git push. And now we are going to try it by making a new commit on the left repository, pushing it to origin, and then doing a git pull in the terminal in the right repository. So in here on the left repository, we add a new line just like before, M4. We stage the change, create the commit, M4. Like this. And yeah, I think we were pushing it from branches. I found out that sometimes this sync button doesn't work perfectly because of the authentication with GitHub. And but this one is more reliable, the push button on the branches section. So now it is pushed. We can check it in GitHub. We see it has M1, M2, M3, and 4. And now in the terminal on the right side, I'm going to move it a little bit. Now we can simply do, so we are on the main branch because we don't have other branches. And we can simply do a git pull. And if we do a git log, we see that it brought over the M4 commit. In some cases, git push can fail because we are trying to overwrite commits on origin, and we will reproduce this situation right now. So in our right repository, we are going to add a new line in here that will say M5 write, and this one will conflict with another commit that we are going to create on the left repository that will add the line M5 left. So in here, we stage this change just like before. And let's call this one M5 write as a commit message. And again, on branches, we do the push. Okay, so now if we go in here and in the GitHub, we see that we have M1, M2, M3, M4, and M5 write. And if we go to the left repository, where we are going to create a new commit in here, which we will do name as M5 left, that adds the line M5. And the commit message for this one will be actually we need to stage it first. So M5 left, we commit this message. Okay, and now we will try to push this. We will try to push this commit from the terminal and see what happens. So, on the left side of our terminal, we will try to run git push, and this one will say rejected. And there are a few solutions in here. If you search on the internet, one option is to do git push -- force, but I would strongly advise you against doing this because you can run into disasters. And instead, what you can do is to simply do a git pull, and this will try to pull the change from origin, which brings in the M5 write command, and that one will clash with our M5 left commit, and we will run into a merge error. We'll see it shortly. So we do git pull, and now we get this error message. It says we have divergent branches, and we need to specify how to reconcile them. So now Git asks us to actually define a strategy for our git pull. So by default, we can choose to resolve the conflicts when doing git pull using the merge method, which is the default strategy. And I strongly recommend using this one. It gets us out of a lot of trouble. If you're like a Git rebase expert, you understand everything about it, then you can use Git rebase and also fast forward. If you don't understand what fast forward is, then just stick with git merge. So we need to config this method in here, and now we can try doing git pull again. So now it just git ended with the merge conflict that we can address in our repository. So in here, just like we saw in the second video, let's say we accept both changes and save this file. So now in here we just need to mark our file as our merge conflict as resolved, and now we click on commit. So, and now if we look at the git log, we see that our history has both the right version, the left version, and also the merge commit. And if we look, actually right now, origin is not up to date, but if we push the changes from our branch and go to GitHub and refresh, we will see that we have the same history again, M1, M2, and 3, then M5 right and left, and the merge commit. So now we can also bring our right repository up to date, because right now it only has M5 right as the last one. But if we do a git pull and git log, we see that it brought over the M5 left and the merge commit. So just in conclusion, I recommend you, unless you're like a Git rebase expert, you select your git pull, you set your git pull strategy to merge, which is the default. And if you run into conflicts when trying to run git push, don't do git push -- force. Instead, do a git pull, which will try to merge your branch with the origin main. And then after you did the pull, you will be able to do git push. Next, we will see how we can work with branches when using remotes. So we are going to open the left repository, and we're going to create a branch in here and send it over to the right repository again via origin. So in here, we click on the main branch and we create a new one. Let's call it F1. And in this branch, we are going to add a commit. So just add one line, F1. We stage the change and create a new commit message. So now if we go to the branches section, we will see that in here there is this cloud button that says publish branch. So publish F1 to origin. And now if we go to origin and we reload, actually no, it's a different one, this one. So if we go to origin and we reload, we will see that GitHub already found the branch we just pushed. It says F1 and we can actually create a pull request. We won't do this now, we will do it later. If we want to see the history of our branch, we switch to it in here, F1. So we can see the contents of our file. And also we can look at the history and we'll see the F1 commit on top. And if we switch back to main, of course, we won't see the F1 commit. And now the right repository, if we look in the remote section, we see that the right repository doesn't know about F1. So we need to do a git fetch on the entire remote. And this will bring the branch to the right repository. And once it's here, we can switch to it. And this one actually will create a normal branch locally in the right repository. And we have the chance to rename it. And usually if you're getting branches from another person, you can change the name. Let's say if Bob works on, if you are using the F1 branch that Bob created, you would do something like Bob-F1 or whatever convention works for you. In our case, we can do, let's say, left-F1. And this branch will track the F1 branch on our remote. And we see that in here we have, we got the latest line F1. And just like when we work with main, if we want to add commits on this branch, we can do something like F2 in here. So we save it, and then we can stage this change, create a new commit, let's say F2. And now, again, we need to push our changes to origin first. Push in there. So now if we go to F1 in GitHub, we see that it has the F2 commit. And if we go to our left repository and we refetch the F1 branch, we will see it identified that it has new commits on origin, and we can also pull the changes into our local branch in the left repository. So we see now that we have the F2 commit from the right repository. Now we'll do the same thing, but we are going to use commands in the terminal. So we're going to send a branch from the right repository to the left one. And in here, let's see what branch we are on. Okay, so we are on left F1. We need to be on master. Check out, actually on main, not master. So now we create a new branch. Let's call it feature 2. And we need to switch to it, git checkout, feature 2. And in here, we are going to add a new line, let's say feature 2, 1, in file.txt. So now if we do a git status, we'll do a git add -p again. Okay, we add this change, we stage it. So now if we do git status again, we can commit. We say feature 2, 1. And now we can push our branch to origin using git push. And it asks us to select which upstream we are using. So we use the command they suggested. So this one will be the origin that we are pushing the branch to. And this is the name that it will have on origin. Like this. So now if we go to GitHub and we reload, we see it right here, feature 2, and it has the feature 2.1 commit, and this is good. So now on the left side, if we do a git branch -a, we see that the left repository doesn't know about feature 2. So we need to do a git fetch. And now if we do git branch -a again, we see that it has knowledge of feature 2. So now we can create a new branch. Let's say write feature 2, and we need to add another argument saying which branch it is tracking, and it's this one over there. So now if we do a git branch, we see that we have 3 branches locally. So we can do a git checkout on the new branch that we just created. And in here we see that we have the commit feature 2.1, which was created on the right side. And again, we do a git push just like before. So if we do feature 2.2, we add a new line in here. So we create a commit. Let's do a git add -p. Yes. Git status. The file was staged. So now we can add a new commit, feature 2-2. So now if we do git push, let's see the upstream branch. Yeah, what happened here? Yeah, let's try again. Yeah. So we need to push feature 2 to origin. So now if we look in GitHub, we see that we have both lines. And on the right side, we can do git pull again. And if we do a git log, we see that the commit from the left side made it to the right side. Now we'll see how we can transfer the commits from a branch into main once that branch is ready for production. So let's say we want to transfer the commits from this branch F1. So we see that this branch F1 has the commits F1, F2, and then this merge commit, and these are all commits that also the main branch has, and we can check here. So we see that main has M5, then the merge commit. This one is a commit that I added off camera. I tried to do something and it didn't go well. So after this operation, the main branch should get F1 and F2. And the first step is to transfer the commits from one branch into main, just like we discussed in the second video. There are 2 options that we can use. This very safe option is to merge the feature branch onto the main branch, but it creates a bit messier history. However, it's much safer. But if you are confident in your git rebase ability, then you can do a git rebase. For now, we're just gonna play it safe and do a git merge. So we need to be on the main branch. We'll do it from our left repository. We are on the main branch in here. And we go to branches and right click on the branch that we are trying to transfer, in our case F1. And we'll do merge branch into current branch. So it says it will merge two commits. Yeah, it looks like we ran into a conflict because I added this M6 commit at the end, and the feature branch has F1 and F2. And we are going to address this merge conflict by accepting both changes like that. Now we need to mark our file as the conflict as resolved, and now we committed the merge conflict. So now we do just like before. We push our main branch into origin. And now if we switch in here to the main branch and we reload, we will see that it has F1, F2, and these two were the commits from our feature branch, the branch that we are trying to transfer. M6 was already on master, and also the merge command added this commit in here which is the merge commit. And lastly, I want to show how to do pull requests in GitHub. So first, we need to create a branch on our repository. We're working on the left one again. So let's say in here, create a new branch where we are going to call it G feature. And in here, we go to our file.txt, and let's say we add one commit for now. Let's call it G1. And we stage it again. The commit message will be G1. So now we can push this branch to our remote, publish branch, publish G feature to origin. So now if we go to GitHub, GitHub identified the branches we just pushed, and we can create pull requests from there. So our latest branch is this one, G feature. So in here, if we scroll down, it shows us what changes are included in this branch. So the changes that we added since we diverged from main. And we see that we only added the G1 feature. Here we have the option to add a description to our pull request. Let's say work on the new G feature. Here we can add a description. And usually you add a bunch of reviewers, a bunch of your colleagues. In here, I don't have any people added to this project, but if you had, you can add them as reviewers. And then you create the pull requests. And here, GitHub integrates with continuous integration. So if you have something set up, it will run all the unit tests in the project, and it will tell you if they passed or not. Also, if you add new commits, let's say we add a new commit in here, G2, and we stage the changes again. We create a new commit, G2. So now if we push the changes to origin, and you see that GitHub already identified that we pushed a new commit, G2. And if we go to files changed, it will show us now that we modify two lines, G1 and G2. And the idea is that your reviewers will go over the changes that you're doing, and if everything looks good, they can approve the changes. Otherwise, they will request that you rework some sections. You can go back and forth with them. And finally, when everything looks good, they can approve your pull request. And then that means that you can merge it into the main branch. And you can do that from your repository using git merge or git rebase, but also GitHub also gives us this user interface for merging pull requests more easily. So in here, we can click this button, and that will transfer it using git merge. We can use rebase and then merge, and in the end, it ends up with the merge. So we can click this button in here like this. And now it also lets us delete the branch because we transferred the work, we no longer need it. So now if we go back to the code section in here and we look in the commits, we are on the main branch and we can see the G1 and G2 commits we had on our feature branch, and also it added this merge commit. And lastly, I would like to do a recap of the concepts we discussed and terminal commands that we used. I'll save it in this notes.md file that I am going to link from the video description below. Okay, so if we're trying to pull an existing repository from GitHub or a different service to our local machine, the command that we need to use is git clone and then repository URL and the local directory in which we want to save, in which we want to create this repository. So directory name. If we don't specify the directory name, it will be inferred from this URL. So it will be the word that is before .git. So let's say pull repository from the internet to localhost. Then if we already have a repository locally and we want to add a remote to it in order to push and pull commits, the command that we need to use is git remote add, and then the name of this remote. If we only have one remote, the name typically is origin, and then the repository URL again. And this one will add a remote to our repository named origin. And if we want to list the remotes, git remote without arguments. This one just list the remotes of our repository. Then we will start working on our local repository. Let's say add commits. And we can push our local changes to origin by doing git push. Let's say push changes from local repository to origin. If we are on a different branch other than main, the git push command might prompt us to specify which origin we are using and what will be the name of the branch on the remote. So this one pushes changes. If we want to pull changes, then we need to do either, first we need to do a git fetch. So it fetches all the changes from origin. The branch names will be something like remote origin main or remote origin feature branch, etc. So this one fetches all the changes, all the branches, or we can also run it with the single branch. Git fetch origin main fetches the changes for a single branch. Once the changes are fetched, then we need to transfer the changes from these remote branches to our local branch. So then we transfer changes from remote branches to local, and we can do something like git checkout main or master, and then git merge, let's say remote origin main. Or if we're working on a feature branch, git check out the feature branch and git merge the feature branch. And if we're using rebase, then we can, let's say, rebase the other branch on top of main and then rebase main on top of that one, but that is more advanced stuff. The basic workflow, just check out main and merge the remote onto main. And also there's a different command that combines a fetch and a merge or a rebase. It can be configurable by us. So combines fetch and merge, and that one is git pull. If we rewrote the history of a branch, then git push might fail, and you might be tempted to use git push -- force. And I would recommend to not do it. Instead, just do a git pull and then immediately push, assuming you set up as your pull strategy to be merged. So if git push fails, then do a pull and then immediately a push. So it will be git pull and git push. Also, when you are transferring commits from a feature branch to main, just do it normally, as just like you didn't have remotes. Make sure you don't rewrite the history of your main branch. So the safer option is check out to main, then merge the feature branch. Let's say transfer feature branch to main. The safer option is git checkout main, then git merge feature branch, and yeah, I guess git push. And that's pretty much it. This is the end of the mini series on Git. If you have any questions, feel free to ask in the comment section below. And if you want to support the channel, please subscribe or like the videos. Thanks for watching.